doctors interested in the average number of adult patients who are overdue for a booster shot. Based on the recent study about daily visits at the doctor's office, an average number of 5 adult patients are overdue for a booster shot when they visit the doctor's office. Daily visits, an average number of 5 adult patients are overdue for this. So it must be the 5 adults out of the total daily adults that visit the office. The doctor believes this average is different than the average quoted in the study. So when you see that word difference when you're doing hypothesis testing, it means you think the mu, the population mean, does not equal 6. That's your H1, your alternative. But maybe you haven't got to there yet. For this question, they say, after calculating the test statistic in a hypothesis test, what does the doctor compare the test statistic to in order to make a decision? We compare a test statistic to like a table critical value to see if it surpasses that critical value. And if it does, then we get to reject the null hypothesis and favor the alternative hypothesis. Okay, so you compare test statistics to critical values. So let me see what else I can find here. The internet's running slow because I'm uploading a bunch of videos. Come on, internet. There we go. Okay, let me see if I can do another one like that. Yeah, this is similar. Katie would like to start a small business. As she writes out her business plan, she is interested in the average number of years until a business turns a profit. So Katie finds out it takes 5 years on average for a small business to turn a profit. So, when we think about that, that's pretty freaky. If you want to start a business, you can't make money for yourself until after 5 years. So if Katie chooses a critical value approach, what does the critical value need to be compared to in order to determine if there's enough evidence to support her claim? Wait a second. This is just like what we did before. It's just, you compare the critical value to the test statistic, okay? The test statistic, I don't think you need me to type this up for this one. If the test statistic is bigger than the critical value, or smaller, depending on whether it's negative, you reject the null hypothesis. So it's kind of the same type of question here. Compare a test statistic to a critical value. Okay, hopefully this one's different. Okay. Well, it says right at the bottom here, what form is the rejection region? So you could get more specifics about it up here, but it's talking about in general what forms a rejection region. So when we're talking about calculating a test statistic like t or z, okay, it's centered at the mean, and the rejection region would be if you get a test statistic that's bigger than the critical value. Okay, these cutoffs, this would be like a two-sided hypothesis test, and this is the rejection region over here. So your test is significant. It means you found something. You found some evidence if your test statistic is over here. This is your critical value, though, and the critical value is really what forms that rejection region, not the test statistic. Okay, you label the critical value and then see if your test statistic is beyond it. Okay. I didn't read this one to see if it was two-tailed or one-tailed, but a critical value forms the rejection region. Hopefully we can get one more here. Yeah, okay. Okay, so you can really just jump to the end with these. You could read the word problem, but what is the probability associated with a test statistic called? Loosely, I guess that's p-value here, okay? Because when here's that drawing again, even worse this time. Let's say this is the critical value, okay? The critical value that you get from that table. This is the rejection region. And then you can get a test statistic. You decide to reject the null hypothesis if this is where your test statistic is, somewhere beyond the critical value. Okay, so this remaining region after the test statistic is the p-value. The p-value is the probability that you get this test statistic given that the null hypothesis is true. So we assume that there is no effect. What's the probability that we actually get this type of test statistic, assuming that nothing's really different? That's kind of convoluted, but basically the idea is that the test statistic helps you calculate the probability for a p-value.